So this is the build for the structured text program. If you have a little look, we have a power supply taking 240 AC and supplying 24 volt DC to the CPX CEC PLC, and you can see the orange lights at the minute are telling us we're in stop. This Ethernet cable here is linking the laptop with the program on it. We've yet to download it. Our input module there is linked to these banana cables. So the start button here is linked back to bit 0, stop button to bit 1, a 0 roller switch is linked to bit 2, and A1 roller switch is linked to bit 3. And then this is the output coming to the solenoid here. So the directional control valve, little 5-2 directional control valve with one solenoid, and then we have the double acting cylinder and the 2 roller switches. So if I go to the program, and because of my Ethernet cable plugged in, I can go to PLC configuration, highlight CPX CEC, go to network configuration and search the network. It has found the PLC. That and set it as the active PLC, I should then be able to go online, make sure simulation mode is unticked now, and go log in. And yours will most likely ask, do you want to download the program? And if so, press yes. So at the minute I'm linked to the PLC. So for example, if I were to press the roller switch here, I would see that bit input bit 3 come on. So at this stage then I can go online and run and show you program, and at the minute you can see that the run auxiliary is false. A0 is true because the cylinder is fully retracted. If I press the start button, here, the cylinder should work through the cycle. And you can see it went through the 4 cycles. You could see the time delay when it was in the extend position. Everything was working fine. If I press the start button again, the cycle starts again. And again it went through the 4 cycles. If I press the start button and let it get to mid-cycle, and then press the stop button, it returns to the start position, which is exactly what we needed in our example. It needed to return if the stop button was pressed, and if I press the start button again, the system should start up again. Now the system is working fine, but before I made the video, I downloaded the program that we wrote in the previous video and found a couple of faults, so I'm going to point these out to you and show you the changes that I made. So in the previous video, what we ended up doing was in the start-stop sequence. I'll log out so that we can see. In the start-stop sequence, I was setting the counter false, counter input false here, and I was setting the timer input false here. And what was happening, if we have a look at the hierarchy, the way I'm calling them to the PLC_PRG, the first priority goes to the start-stop cycle, and then sequence and counters and timers. So what's happening is, in the start-stop program, this one, is taking priority over the rest. So because I had said else if stop button, then reset the counter input and reset the timer, that was causing us an issue. So instead of doing that, I changed it around, and in the sequence program, for the very first, within the zero case, I decided to go if the runox and A0 on the counter, so that would mean that the counter has reached 4 cycles and it's given a signal out on the Q value, then everything is basically set false. So it'll sit there dormant and wait until everything becomes correct. And this is where the else if command comes in. So the else if, if we have the runox, which means the cycle should start as long as we have A0 active, and we don't have a signal from counter 1Q, so I'm not counter 1Q, then AXTEND goes through and it moves on ahead through the cycle. So this fixed an issue that I was having with the program from the previous video. The issue I was having was the whole system would work through the cycle fine, but if the stop button was pressed, the system wouldn't start again with the start button. So you can correct yours, and